Good day, ladies and gentlemen. This is Sarah van Grennen with the third video on standard deviation. And in this video specifically, ladies and gentlemen, we are going to look at exam questions. So how does the examiners expect you to be able to answer standard deviation questions? We've done the theory, we've done the understanding, but how will this be asked in an exam setup? So I want you to go and try this sum that we asked similarly to our matrics last year. When I look at the first question, it says that, okay, let's first read the information. I'm just jumping into the questions without reading the information proper. So it says, at a certain university, only 12 actuarial sciences students take discrete mathematics and economics. The marks as a percentage scored by these students in the semester exam for discrete maths and economics are shown in the table below. So first question, calculate the mean percentage, so X bar. So I can add all the numbers together, divide it by how many there are, but also remember, you can now use your calculator. So you can put it on stat function, crunch those numbers, and get a standard or a mean of 68. While it is on, on stat function, you can press those buttons and get the standard deviation, so sigma, and that's 18,42, okay? Now, at this moment of time, we are going to look at question C on the next page, but it says, determine the number of students whose percentages in discrete maths lie within one standard deviation of the mean. So looking at this, I'm going to find this interval within one standard deviation of the mean. So I'm going to go x plus sigma and x minus sigma. Now remember, your x bar or your mean is 68, while your sigma is 18.42. If I now calculate this, the bottom barrier or your bottom boundary is 49.58, while your top boundary is 86.42. Let's have a look at my data set. I've got all the circled red ones lie within one standard deviation of the mean. 52, 82, 71, 65, 77, 57. So this means there are 6 data entries that fall within one standard deviation of the mean. Now, this is not a very good spread of data. If you look, there are 6 that lie within, 6 that lie outside. So let me just carry on. The next question is, now these kind of questions we love to ask. If all the marks for economics is increased by 3%, what would be the effect on the mean and the standard deviation? Let's talk about mean first of all. Remember, mean is your expected value. Now, if I look for the expected value and all of them increase by 3%, well, then your mean is also going to increase by 3% because all of the values are increased by 3%. Again, just think about this. What does the mean? I'm sorry for making that really bad joke, but what does it mean? It means if I pick someone at random, I expect the economics mark to now be increased by 3%. But does that change the consistency? Does that change how close or how far the values lie from the mean? No, because all the data is moved up. So everything is moved up. So it doesn't mean it is more spread out or less spread out. It's just the same spread, but just a little bit higher. So in other words, my sigma remains the same. So I'm going to have the same standard deviation. And I'm telling you, you can actually go there and calculate it, and you will see that the standard deviation is exactly the same. Now let's look at the next question. One student with a discrete maths mark of 20% was overlooked when entering the marks. Describe the influence on the standard deviation. Okay? So when I look at my data entries, the data entry that I need to put in, the 20%, right in the front there, it does not fit any of the rest of the data. So in other words, it is much, much lower than the rest of the data. I mean, the closest to it is 42, which is more than double that. Now the question is, how will this influence your standard deviation? Will this make the person more consistent, or not the person, sorry, the class? Will it make the class more consistent, meaning closer to the average, or will it pull it further apart? Definitely, it will pull it further apart because now it is less consistent. It lies further away from the mean. So therefore, my standard deviation is going to increase. But I've got a question for you. What would that 20% do to the mean? Well, because it is lower than the mean, remember, was about, how much was it? The mean, let's quickly go back. The mean was 68. Now I'm putting this data in, the 20% there. What's it going to do to the mean? It's definitely going to lower it. So even though it increases the standard deviation, it's actually going to lower the mean. Ladies and gentlemen, I hope you enjoyed these videos about stats, about how we're going to ask stats. Definitely ogives, definitely box and whisker diagrams, and they are going to ask you about standard deviation. Guaranteed. But have a gorgeous, amazing rest of your day. I hope that you stay tuned for our next videos. This is Mr. VG signing out. Cheers.